Section 1.4 is on relationships between lines and parts of lines. We are going to talk about two specific pieces of lines. Remember that lines go on forever. We're going to talk about a segment, which is a piece of a line. It has a starting point and a stopping point, and a ray, which has a starting point but not a stopping point. So by definition, a segment has two endpoints, a beginning and an ending. They are named, we name segments specifically by those two endpoints. So if this is our segment, it would have two endpoints here, and they will be labeled. Because they're points, they'll be labeled with a capital letter. So for example, D and E. So we would name this DE or ED, order doesn't matter. But instead of putting the full line symbol over the top like we did in the last section, we will simply put the segment symbol over the top. Notice there's not an arrow on either end. That's our clue that it's a segment. Okay? Segments can be measured, lines cannot. Since lines go on forever, we don't measure them, but line segments can be measured. Rays have a starting point, so we will name them by their starting point, and then regardless of how many points are labeled, just pick one of the other points that are somewhere on the ray. For example, if this was B and C, we would name this BC. The trick with a ray, though, is notice one side has an arrow. So when you go to put the symbol over the top, make sure whichever side has the arrow, that's the side that you put the arrow on the symbol. Since it's starting at B and going through C, we have to put the symbol going that exact same direction. The symbol looks like it's starting at B and going through C. So that one order does count. You have to be a little more careful with a ray than you do a segment. Rays cannot be measured. Segments are the only part of a line that can be measured. Lines can have relationships between themselves other than just being pieces of whatever. They can be parallel, which I'm sure that you've talked about several times in past classes. Remember, parallel means that they are coplanar, means they're on the same flat surface, and they do not intersect. They stay exactly the same distance apart all the time. Now, segments can be parallel, rays can be parallel, lines can be parallel. All of those things can be parallel. Also, planes. If you remember, we talked about planes being flat surfaces. Two flat surfaces can be parallel as well. If you think about holding up two sheets of paper, hold up one sheet of paper and then hold another one a little ways underneath it, those sheets of paper would be parallel planes, or would show parallel planes. Okay? The symbol for parallel is exactly that, two little parallel lines. So if I was going to name this ray AC, and I was going to name this one DF, I could put AC on one side and DF on the other. Now, I have to put the symbols over the top so I know that they're rays. So I'm going to put the arrow over the C here and the arrow over the F here. And this would say that ray AC is parallel to ray DF. For those of you that don't like to spell, this is a really nice way to get around spelling the word parallel. The other relationship that lines can have, if they're not parallel, they're either going to be intersecting or they'd be what's called skew lines. Okay? Skew lines are non-coplanar lines that do not intersect. So if you've ever just been told two lines that don't intersect are parallel, that's not quite right. If they're on the same flat surface and don't intersect, then they're parallel. Excuse me. But if they don't intersect, they might be skew lines, which means that they're not on the same flat surface. A diagram is drawn here for you. Notice that this line is going vertically up and down over here, and this line is over on the side going horizontally. So if you have one line over here going vertically and one line a little ways away going horizontally, those two lines are never going to intersect, but they are clearly not parallel. That's an example of skew lines. There is no symbol for skew. We just have to write it out that those lines are skew. A couple of examples. If I was going to name a segment in this picture, first of all, there are several segments, several different segments. Okay, QR would be a segment, so I could name it QR. Make sure I put the segment symbol over the top. RT is a segment. Okay, SR, SQ. How many segments are there actually? There's 1, 2, 3, 4. Is that it? 4? 1, 2, 3, 4, and 5. 5. There are 5. 6. There should be 6. Anyway, there are, I'd have to name them all out. Let's see here. QR, QS. You don't really care, I bet, at this stage of the game. QT. And, oh, and I should tell you that putting them backwards, like RQ, is just another way to name this one. They are not different segments. Okay? So as you go through and name them, I'm getting off track, but as you go through and name them, doing them in reverse does not mean that they're a different segment. It's just another way to say the other segment. Okay? Naming rays is exactly the same, but it's a little bit different because, for example, ray QR is not the same ray as ray RQ. Do you see the difference between those? One of them, this one, starts at Q and goes through R, so it represents this ray here. This one starts at R and goes through Q, so it represents this ray going this direction. We have a description of rays called opposite rays. And we would say if they start at the same point but go in opposite directions, those are opposite rays. So for example, ST and SQ, those are opposite rays. One starts at S and goes this way, and one starts at S and goes that way. Those are opposite rays. Okay? Example of naming rays, example of naming segments. In this example, it says to name a pair of parallel lines. I'm going to move this over a little bit so you can see it. Name of parallel lines. Okay, there are lots of them in this case. For example, BA and EH are parallel. That would be one example of parallel. In this case, they're segments because they're ending. FG and DC. Those are also parallel. Okay, so you get the idea here. There's lots of them. There's 1, 2, 3, 4, 5, 6, 7, 8. I believe there's at least 8 there. Oh no, 9. BE and CD would be parallel. FG and HA would be parallel. So there's at least 10. All right, naming a pair of skew lines. Skew lines, remember, can't be parallel, but they also don't intersect. Okay, so I'm going to start with EH, line EH. Find another line that is, to find a line that is skew with EH, it can't be parallel, so it can't be BA, but it also can't intersect, so it's not going to be EB or EF. So for example, EH and BG, those are skew. You've got one going up and down, the other one going a different direction, but not intersecting it. That would be a pair of skew lines, and there are lots of skew lines as well. All right, that finishes out this lesson on lines between, or relationships between lines. There is your homework.